Good morning, friends. And today's session, we will explore how to perform an experiment using Azure Machine Learning Studio. Now, Azure Machine Learning Studio is one component of by Microsoft for machine learning. We have Azure Machine Learning Service also and Microsoft Cognitive Services. The one we are considering Microsoft Azure Machine Learning Studio. It's a primarily UI based and it's limited to 10 GB of data. It doesn't support pipelines, but it is very handy to validate your first modular when you are just started working on your data for analysis and modeling. And it also gives you the feature of once the experiment is done, you can set it up as a service which can be consumed by other applications. So with no further delay, let's have a quick look and get you introduced into how to create an experiment. Now, experiment is the basic unit of work here in Azure Machine Learning Studio. So if you on this left you have different panels. um, so we can go one by one. So here the first things are the projects, and under a project you have an experiment. See, so project is a sort of a placeholder of all your resources. uh, so you have experiments here, any experiment you want to create on your own, and if you want to view existing samples that are pre-built, you can explore here. You can look at any web service that you have exposed using your experiment. You can also access, you can create notebooks for your experiments to run, like Jupyter and Zeppelin. You need to work on data while doing machine learning. So Azure Machine Learning Studio gives you certain sample data sets bundled with it, or you can use your own data set. So let's look at the experiment. In the brevity of time, I'm just using an existing experiment that is created, and because as I am on a metered internet connection, and when you run experiments, it takes a bit time to run, and if you are recording it, unless you do an editing afterwards, the time it takes to run is bit large. So to keep it brief, so I've just done the experiment and I'm just recording for your benefit and hopeful usage on how to do it. Okay, so here let's look at a recent experiment I have done. So if you want to, okay, so there are two tabs. One is predictive and there is training. So we will look at the training. So our experiment that we have, you see there is a new menu here. So if you click on this new, you can do all these new things. You can and create a new experiment. You can, so there are different templates also. So we start off with a blank experiment, and within the blank experiment you can give it a name, any name you want, and this is how it would work. So for us, we'll just go back to our experiments. Okay, so you start with a new experiment and you give it a name. Now after you give it a name, we start off with a data set. Now data set, as I told you, you can use a bundle data set, which is here in the samples, or you can use your own data set. Now to bring in your own data set, you go to new and then you go to data set and then you upload from a local file. Okay, so once you do that, you will see under your my datasets the file that you have used. So I have used here the iris data set, which is quite common in use. So here I've just modified the class variable from three different types to two. So the species I have just trimmed it so that it has only two different types of species, so that we can use say logistic regression with two categories. So y- once you have your experiment, you first thing is you drag and drop your data. Okay, now once you put your own data, you once you click that, you look into the you can visualizes that what is the data set. So let's have a look. So it tells you that it has 100 rows and 5 columns, and it tells you the column names that it has, and this is my label variable species. Okay, and it also tells you some different distribution of it. So if you click on one of the column names, you will see the descriptive statistics against those columns. So once you have it, so I have uploaded my data set, and I have just used it from my data set palette here. Now once I have the data, I can split it to training and test. So if you need anything, you just type it here. You see that under the data transformation sample and split, you have split data. So I've dragged it here, and once you have the palette, you have different properties. So here in split data, the here what we have configured is we are just telling that what is the fraction of your test and training. So here they have given the value of 0.8, and rest I have gone with the defaults. Now once you run this split data set, you will have two data sets as output. One is your training, and the other one will be your test data set. Now after you have split your training data, you one important thing is to use this palette of edit metadata. So if you look here, edit metadata is again under the transformation and manipulations. Now once you click get this, so you need to select which column of. So the basic purpose of edit metadata is you need to give metadata information for your data set, so that your studio knows. So here what we're basically telling is, out of the 5 columns, the species column is the one which is our label, which is the class, which is the predicted variable. So how do we do that? So we just drag and drop the edit metadata, and then we go to the column selector, and then in the column selector we select the species column. Now once you have selected the species column, you see here the species column is already selected. Now in the fields drop down, you mark that the species that we have column that we have selected is of type label. Okay, now this is important because it tells that okay, that's going to be the predicted one. So once you have done that, you save it, you can run it. Each of this you of the experiment you can run um, the whole experiment, or you can run a selected cell. Okay, so we have now till edit metadata. Now we have seen that we want to go for a binomial classification here. So we use two class logistic regression. Now whatever model you want, there are so many different types of model. If I see under this machine learning initialization classification, we have two class logistic regression. It creates a two class logistic regression model. So I just drag and drop that model. So if you look at the properties of the model, you can specify L1 regularization weight or L2 regularization weight. So we are just sticking to the default. We're not doing any changes here. Now then you need to run this model, and then so well, now you have the model in the experiment, you have the data. So now we bring one more palette, which is called you need to train your model. So the model needs to be trained on the training data set. So we uh, pick out the train model, which is under machine learning and train. Now once we have the selected train model, we join the model and the test data set, that is the metadata one. Now and then in the train model we just select the column species here. Okay, now once you have selected the species, so this is for your training. Now you run this experiment and by clicking on run train and model, or you can just go with the primary run. Now you, and after you run it, you have trained your model. Now you need to score your model. So similarly, just like train, you have score. You have score model also. You can use that palette. So score model palette, you drag and drop it and drop. If you look at this score model, you need the model and you need the data to score into predictor. So we will be using the test data set that we have. Now one thing that we need to configure more in score model property is that we are checking this append score column, so that whatever is the predicted value by the model, we want it to be appended. So we have 5 columns in our data set, all the sepal length, sepal width, petal length, petal width, and species. Now species is the one we are predicting. We already know from our data that which observation stands for which species, and we have trained the model, we have testing it, and we want the score on how it performs. We need to compare that, so we are appending the predicted column as same into the data sets itself. Okay, now when you run the score model, so you are good to go. Now you can visualize the score data set. You see here we have that test data had 20 rows. The initial test data had 5 columns, but we have after the prediction we get 2 more columns, which are scored labels and scored probabilities. So for each of the if you look, that the original level was Setosa, and the scored level is also Setosa. Okay, and probability is also mentioned, given there. So this is in brief, in a very brief, on how you can create a logistic regression on experiment on a data set. So hope you find it useful, and there are more parts to it, like once you have created the experiment, you can evaluate it, and then you, after the experiment is run, you can set it up as a web service. So there are few other things, so we'll take it in the next session. Thank you.